Hi everyone, welcome back to Prieto TV and welcome to the new episode of Prietology. So what I'm going to try to do in this series is transfer my knowledge of science to you guys and trying to make it in the simplest way possible. So what I'm going to do is these episodes of Prietology will be every other video. So this video is Prietology and then the next video will be a challenge video and then the video after that will be Prietology. So if you watched the latest episode, you would have learned that we talked about the basics of chemistry and the states of matter and melting points and boiling points. Today we are going to take that with a little further, so let's get started. Okay, so as I said, this is a new episode of Prietology. The title today is The Building Blocks, like I said. So today's episode, we're going to be talking about basically what elements are made of, so like atoms, protons, neutrons, molecules. So we have our key terms like last class. So we have atom, isotope, ion, molecule, polymer, metallic bonding, nanoparticles, Avogadro's number, and mole. Okay, so we shall start with atoms. So atoms, they are the building block of element. There are 118 known elements, which means there are 118 known atoms. So atoms are made of protons, which is always represented with P with a plus sign, neutrons, which are represented by N, and electrons, which are represented by E with a little negative sign. Protons are positively charged, and neutrons are neutral charge. They have no charge, and electrons have negative charge. So electrons orbit the atom. So let me get my model atom. If you remember my model atom from last one. Protons, I'll draw helium atom. So helium, 2 protons, 2 neutrons. So these are my protons, these are my neutrons. And what I mean by energy shells is the orbit that electrons take. So here's an electron. So electrons always orbit, so they have different shells. So like, as I said last time, the periodic table is organized into rows and columns. So when you go by each row the shells get bigger. So in the next row there'd be 2 shells. So with another electron, so another electrons, and then a third shell, then a fourth, and a fifth, and then it just keeps going and going and going. Okay. And then I think I briefly mentioned atomic number last class. The atomic number of an atom is based on the number of protons in the nucleus. So if there are 2 protons, it's element number 2. If there's 3 protons, element number 3. You get it. And also, this is just a number, a little fun fact. The number of protons is always equal. It will always equal the number of electrons. So if there's 6 protons in the nucleus of the atom, there would be 6 electrons on the outer shell. So the mass number equal to the number of protons and neutrons. So if the nucleus of the atom has 6 protons and 2 neutrons, it would be 6 plus 2 is 8, so the mass number would be 8. Okay, so now that we discussed atom, there's another part of atom. This is, for me, is like the evil twin brother of atoms. It is called isotopes. Isotopes are atoms with same atomic number, but with different mass numbers. Okay, so this might sound confusing, but basically they're atoms that contain equal number of protons, and then the neutrons, they have a different number of neutrons. So it has 1 neutron and then it still has 2 electrons. So they still have 2 electrons. So that would be an isotope. So isotopes that decay are called radioisotopes because of radioactivity, which we will discuss in another season. So an example of an isotope, I'm pretty sure if you've heard this one, it's called carbon-14, which is written like that. Carbon-14 is used for carbon dating, which is for like figuring out the age of the Earth and the age of fossils, and that's pretty much one of the main primary uses of radioisotopes. Okay, so we discussed atoms and we discussed isotopes, but wait, there's another part of atoms called ions. The ions are atoms that have gained or lost an electron. So basically, I mentioned atoms a lot in last week's episode. So ions, so let's say we have our atom here, so we have protons, neutron, and 2 electrons. Okay, so ions are held together by electrostatic forces. We'll get into electricity later in this series. So ions transfer electrons to outer shells of atoms. So let's say this is the outer shell of my atom, and there's one electron here. Ions would be able to transfer this electron to here. So and then they would fill up the shells until they're full. So they would transfer electrons basically to or from the outer shells of atoms to make them up. And this makes them positive and negatively charged ions. And ions can make ionic compounds. We talked about ionic compounds last time. An example of an ionic compound, salt. Salt's a perfectly good example of an ionic compound. So ionic compounds usually have high melting points and also boiling points. Okay, so now that we discussed the three types of atoms, atom, isotope, and ion, we are going to talk about what brings them all together, and that is molecule. So molecules are two or more atoms held together by covalent bonds. If you remember what covalent is, covalent compounds, we learned about that last class. So in the terms of nonmetals, it lets two nonmetals combine, and then they create electrically neutral and stable substances. And it also lets nonmetal atoms to cooperate in filling the electron shells, which I've mentioned a lot, which is shells around the atoms, electron there. And also the bonds between atoms are strong, while the intermolecular, so like a molecule, an example, H2O. So we have our hydrogen, and then we have two hydrogens and an oxygen. That bonds between the atoms, so if I have another hydrogen, I have another water atom, these are very strong, but the bonds between the molecules themselves are very weak. This might seem a little confusing, but all compounds are molecules, but not all molecules are compounds. A compound, like we learned last class, is two elements fused together to create a new substance. So water, for example, is a compound. But what I mean is not all molecules are compounds. An example of a molecule is hydrogen gas. This is hydrogen gas. So hydrogen gas, it's not a compound. It's not a compound because it's not two different things. It's one molecule, and it is not a compound. Okay, so now we've talked about molecules. There's a different type of molecule. It's called a giant molecule. Those are molecules with a lot of bonds. And a really good example of a giant molecule is polymer. A polymer is a giant molecule that has many useful forms. Molecule that has very useful forms. So basically, a polymer is a bunch of repeating hydrocarbon molecules. And if you don't know what hydrocarbon is, they're molecules with basically like skeletons of hydrogen and oxygen. An example of a hydrocarbon would be water. So examples of polymers that you probably know is one, plastic. Plastic is an example. PVC is an example. Rubber, as in this rubber. And also another key characteristic about polymers, they are very flexible. You can manipulate their shape while they're in solid. So like rubber, you can manipulate their shape because they're a polymer. Okay, so our next term is metallic bonding. This can get a little complex, but I'm going to try to simplify it. So basically metallic bonding, it's one of the three types of bondings. The other ones are ionic and covalent. So metallic bonding is the reason why metals behave like metals. So basically if a metal is superconductive, it's because of the metallic bonding. If a metal has a high melting point, it's because of covalent bonding. So like I said, the properties of the metal depend on the way of metallic bonding. So the metals during metallic bonding, they're held together in a lattice of positive ions. An example of a lattice, if you don't know what a lattice is a badminton racket is a good example. As you can see here, this is like a lattice is basically like this square checkerboard kind of pattern. So basically, they're made in a lattice of positive ions. So I should put some ions like that. And they're held together with the bonds, so they're basically held together like that with C's, as you say. Most people say C's with C's of seeds of electrons. And metals are usually held together by electrostatic forces like ions. Okay, so our next term is the nanoparticles. Nanoparticles are, well, nanoscopic particles. And if you don't know what a nanometer is, 1 nanometer is equal to 1 billionth of a meter. So a nanoparticles usually range in size about from 1 to 10 nanometers. So basically they're little tiny little particles that have, as I say, cool properties. They're able to change a substance completely different. So basically silver naturally can kill like germs and bacteria. But if you add nanos and then it creates nanosilver, it can create superbugs. It can kill superbugs that can basically wipe out the entire planet. And zinc oxide nanos absorb UV light. An example where you can find nanoparticles is in sunscreen. This is zinc oxide. These usually have nanoscopic particles which can block and absorb UV light so you don't get sunburned. Okay, so the next term that we're going to talk about, these last terms, Avogadro's number and mole, they're related in very specific ways, but we'll start with Avogadro's number. So the number is named after some guy named Amedeo Avogadro. That's how you say it. So Avogadro's number is a number that says there's a number that says how many moles, not the animal. I think I briefly mentioned moles last lesson. Moles are basically it's a chemistry unit of measurement. So RAR and a molecule of gas. It usually works with gases, and this special number is 6022 followed by 20 zeros. So I'm not gonna write all the zeros. So 6022 followed by 20 zeros. And the number equals the Avogadro's number. It always equals the number of particles in 1 mole of substance. And we'll get to mole right now. Okay, so our next term is mole. Mole is a chemical unit of measurement. So 1 mole is represented with just lowercase m-o-l. 1 mole is equal, I don't think you need to know this number, but 1 mole is the Avogadro's number. If you want the Avogadro's number simplified down, it's 6.02 times 10 to the power of 23. So 1 mole bit of element or compound always contains the same number of atoms or molecules given in Avogadro's number. It's a little complex, but what I'm trying to say is the weight of each mole, which is the Avogadro's number, is equal to the atomic mass of each element measured in grams. So I'm going to try to simplify this to understand. So 1 mole of, let's say, elemental oxygen, so just O, equals 16 grams. And then 1 mole of gaseous oxygen, which is O2, equals, since it's 16 grams, it would be 16 times 2, because there's a little 2 here, so 16 times 2, which equals 32 grams. So 1 mole of gaseous oxygen would equal 32 grams. Well, I think we covered all the terms for today, so let's get on to experiment of the day. Okay everyone, this is experiment of the day. So today's experiment is seeing how water molecules, as we learned today what molecules are, react with heat. I mentioned heat a lot last class. So basically what heat does, it can melt solids, it can melt liquids. So heat is basically responsible for making the different states of matter change. So this experiment is great for testing how hot water molecules can react with cold water. So basically what you need 2 clear glasses, 1 filled with hot, 1 filled with cold. I'm gonna go fill them up really quick, and some food coloring. Okay, so I am back with the glasses. This one is the hot water, this one is the cold water. So basically what you have to do is I put the blue first is gonna be for cold and the red is gonna be for hot. So I'm gonna put 1 in each. So if we could bring the camera down, so I think we could get a better look at it. So we're gonna put, this is the red water first. So no, the instructions just say to drop it in. So let's put in a drop and see what happens. As you see, it goes down very, 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 very fast. And all the heat, as most people say, heat rises, so you can see the color rising very fast to the top. Now, let's try the blue, which is our cold water. So let's put it in. Put like 1 drop. I think 1 drop would be good. Come on. As you see, it falls down much more slowly, and you see the color is most of the color is starting to sink to the bottom. Some of it's going up because of buoyancy. So basically, what's happening is the colder molecules, the food coloring spreads faster more in the hot water than the cold one. So since, like I said, when there's heat applied to atoms, they move faster and faster and faster until they can form different states of matter. So basically, what's happening is that the hot water molecules move at a faster rate, and the cold water molecules move at a slower rate because they're colder. So basically, this is how our classes are going to work. So like I said, every other day, key terms, defining them, explaining what they are. So our next class is going to be about acids and bases. I'm excited for that one. So thank you for watching. Like, share, and subscribe. Get this video to the front page, and I'll see you later.